Hey guys, this is Math 148, section 14.1. You guys are going to like this section because there's no derivatives and no integrals, unless you really like derivatives and integrals, in which case I'm sorry to disappoint you. So section 14.1, we're looking at functions that have two variables. So all of chapter 14 is functions with two variables. So what does this look like? Well, here so far we've been doing functions with one variable, and that looks like this. Y equals 4x squared plus 5x plus 6. That will be a parabola. So that's just, there's one variable here, but mainly in this part there's only one variable, the x. Well now, suppose you had a different function, z, that equals x squared minus 4x times y plus xy cubed. That is a function, z, is in two variables, because this part here, there's two variables. There's an x and there's a y. So in this one there's only one variable that you could plug things into, and in this one there's two variables. So something to keep in mind with these functions is if you have a function in one variable, the graph of that function is a two-dimensional graph. I have an example here of, this one. That's a parabola, right? The function in one variable. If I go back to this one, z here, this function, this is example 2 in section 14.1. That function looks like this. Isn't that cool? So it's not a flat graph. It's not a two-dimensional graph. It's a three-dimensional graph. It's a surface. So these functions that have two variables, there's an x component and a y component, and you want to start thinking of these as surfaces. And this is a kind of fun little online graphing tool you can use if you want to plot these functions and see what they look like. But for the most part, for chapter 14, the questions are fairly straightforward. So question 13 gives you this function, c of x1, x2, so they're different variables. x1 is one variable, x2 is another. Looks like this, 600 plus 4 times x1 plus 6 times x2. And it says evaluate the function when x1 equals 400 and x2 is equal to 500. So now we're just going to plug in these functions. So we're saying this is 600 plus 4 times, well, we're going to let x1 be 400, plus 6 times x2 is going to be 500. And all of this equals $2,500. So if this was your cost function and these were different variables, then the cost function at 400, this was totally messy, let me redo this. The cost function at 400, comma 500, so you're evaluating at two different points, is 2,500. And remember, I'm using the word function, but the graph of this would be a surface, and I think I graphed it there. Now in this case it's a plane because the neither of the functions were squared. See, that's just a straight, it's like not raised to anything. There's no exponents there. So in this case the function, the surface, looks like just a plane. But that is essentially, these are the sort of problems you're going to be doing in section 14.1. You're going to be practicing plugging different values into these functions that have two variables. So do a few of these and be able to do them. You want to get all the points on this section because there's no derivatives, so make your life easy.